Are there any questions before we resume? Okay, before the break, we did discriminant analysis for a data file about job classification. And we want to predict job membership. Okay, we want to put people in one of the three groups. Group 1, poor performer. Group 2, individual achiever. Group 3, team player. So we want to put people in one of the three groups based on what? Based on X1, friendly, X2, GPA, X3, job history, X4, job test. Okay. And we got the output. We haven't analyzed yet. This is the output from discriminant analysis. Okay, so this is the point we are going to turn to. Analyze the output from SPSS. So pretty easy. Processing summary. Total we have 124 cases. And for group statistics, it is also obvious. Remember, we have 3 groups. So for the first group, poor performer, the average for friendliness is 44. The average for college GPA, 2.95, etc. Okay, so that is for group 1. And for group 2, individual achiever, the average for friendliness, 51, the average for GPA, 3.13, etc. So this is just the descriptive statistics, okay? And the next table, a test of equality of group means. Group means. In this table, we have a new terminology, Vickers lambda. Vickers lambda. Vickers lambda, basically, let me just try to write down something here. So this lambda, Vickers lambda, it is like R square, okay? We hope the bigger the lambda value, the better we will predict the results. So exactly what Vickers lambda measures, it is measure the differences among the means, right? Differences among group means. And if you use the p-value method, so the p-value for friendliness scale is significant, means there is a big difference among those 3 groups for friendliness scales. And the next one, college GPA, p-value smaller than, p-value is 0.005. Okay, you got a very small p-value. So it is significant. How do you interpret it is significant for college GPA? Means the mean value for college GPA across 3 groups are very different. Okay, similarly for job rating, and job test result, they're all significant, means the mean value for rating of job history across 3 groups are significantly different. And also the mean value for job test results across 3 different groups are significant, are different. Okay, here significant means different. The mean value for 3 groups are different. This is what we want, actually. Okay. This is this table. And then we have log determinants. Here we have 3 groups: poor performer, individual achiever, team player. And the rank represent number of independent variables. The rank represents the number of independent variables. Remember, we have how many independent variables in our example? We have x1, x2, x3, x4. We have 4 independent variables. So that's why you get the rank is 4. And during the final exam, I may put rank 3. And I ask you, how many independent variables? The answer is 3. You just look at the rank value, okay? And the final exam, I will change the rank value to 5. I ask you, how many independent variables? The answer is 5, because the meaning of the rank represents number of x. Okay. And we have this log determinant. Okay. So basically, it is actually, we hope the log determinant are as close together as possible, because we want to satisfy equal variance from the box M test. So this is this table. And in next table, test results, box M is 26. If you look at the significant, what does the box M measure? It is measure equal variance among groups, because the p-value, okay, here, the p-value is 0.19. P-value is not significant, means the variance are equal. When p-value here is not significant, means they are equal. What is equal? Variance. Okay, variance across groups are equal. So our second assumption satisfied based on box M. During the final exam, if I give you the significant value not equal to 0.19, I give you significant value 0.0001, what would you conclude about variance across different groups? If the significant value, instead of 0.19, I give you 0.001, what would you conclude about variance across different groups? Yes?
It is significant. All the values are different.
So
variances are very far apart.
Yeah, it is significant, means variance are far apart. They are not equal. Good job. Thank you for your contribution. All right, so those are, how do I test you during the final exam? I will give you the output. I will change the number. I will ask you the meaning of those numbers. Okay, the one I test you always discuss in class. I will not ask you something I didn't do in class. Okay, not 100%, but 95% of the chance the questions are discussed in class already. So this is the test result. Okay, here comes the eigenvalue. Eigenvalue. And remember, we have two functions, function 1 and function 2. Okay. And we have eigenvalue. We hope the bigger the eigenvalue, the stronger the function. Okay. And we also get this canonical correlation. Canonical correlation. In this case, function 1 canonical correlation is 0.506. What does it mean? It is actually like the correlation in regression R. If you square this number, you get effect size. Okay, so let's square it. So what I want to do a calculation. I want to use 0.506 times 0.06, and the result is 0.256. This result is effective size. It is like the R squared. Okay, and it's like 26%. Okay, so 26% of the variability for the fourth discriminant function is accounted for the difference among the three groups. So the second number, a canonical coefficient 0.429. If I square it, I get 18%. What does it mean 18%? Means 18% of the variability of the scores for the second discriminant function is accounted for the differencing among three groups. We have two functions here. Okay, so that is the eigenvalue. Next is Vickers lambda. So we have two functions. First, we test function 1 through function 2. The Vickers lambda 0.608, chi-square 59. We focus on the significant value 0.001, so it is significant. What is significant? Means it is significant that you use 4 variables to predict job category. Remember, we have 4x. So that is significant, means the model is appropriate. So Vickers lambda help us to determine if it is appropriate to use 4 variables. Which 4? Friendly GPA, job history, job test. Use those 4 variables to predict job category. It is appropriate because Vickers lambda is significant. It is actually answered our first question here, the research question here. Okay. The first research question. Are differences between 3 groups On the 4 predictor values, are there differences among 3 groups on the 4 predictor variables? And how do you answer this question? The answer is yes. The reason is based on lambda. WILK, weakest lambda. Weakest lambda is significant. It's on that table. Where is that table here? This table here, weakest lambda. This picture. So that is our first research question. And next, we have our standardized canonical discriminant function coefficients here. So based on these coefficients, you can write down the equation. I'm going to copy and paste to here. Do I have? Try to copy and paste here. Why it didn't give me the option? Okay, that's fine. So you have the original output here. So how do I write down my discriminant function? I have 2. If you have this coefficient, you can write down the function. So the function is discriminant function. Okay, so I will call it DF, represent discriminant function. I have 2, function 1, function 2. For function 1, you have friendliness negative 0.087 times friendliness scale and 0.088 times college GPA, and then you have 0.275 times job rating. Okay, and then keep on going. You have job test result. So this is function 1. Similarly, you can write down function 2 based on those coefficients. So that is you can write down the function. That is the reason when you run this analysis, remember you get this score here. See, you have function 1, you have this number. How do you get negative 1.80? You plug in that function, discriminant function 1. And this is discriminant function 2, negative 2.47, based on discriminant function. Okay. So that is the coefficient. So next, we have functions at group centroid. Functions at group centroid. What does that mean? That means which group are separated by which function. So I'm going to copy this and then make annotation. So this one, this table tells you which group are separate. Which group is separate by which function? Which group is separate by which function? For example, individual achiever is separated by function 1 because it has the biggest value for function 1 here. Okay. So for example, individual achiever. I'll try to make the font bigger, okay? Individual achiever is separated by function 1. In another word, function 1 distinguishes individual achiever with other groups. And then let's look at the second column, function 2. Function 2 separates team players with poor performer. So function 2. Here we ignore 0.03 in the second column because it is already distinguished from function 1. That is the explanation of that table. Which group are separated by which function? Actually, I missed this structure matrix. It's also very important. This is very important table. So now I'm going to explain this one. Copy structural matrix. This is explain function. Oops. So now I'll explain this table, structure matrix. This table explains which variable to interpret for each function. So what does the structure matrix do? Which variable to interpret for each function. Which variable to interpret for each function. So for example, based on this structure matrix, we know job test. So the predictor was strongly associated with function 1 are job test and college GPA. The predictor strongly associated with function 1 are job test and GPA. Those two variables connect with function 1. And because of this, we give a name, meaningful name for function 1. Meaningful. We call it is engineering knowledge. Function 1 is the engineering knowledge because function 1 associated with test and GPA, job test and GPA. Okay, so I give you example for function 1. Now I have question for everybody, including online students. What are the most important predictor for function 2? This might be a final exam question. I give you this table. I ask you, which predictor is the most important for function 2? I will check the online chart. Do I have a volunteer to answer this question? Okay, let's do it together. So in function 2, the most important predictor is friendliness scale because it has the biggest value, 0.859. Okay. So, 我查笔型的 predictor. The predictor strongly associated with function 2 is friendliness. Okay. So thus, we give function 2 a name. Gregarious. Gregariousness. Okay. Because function 2 related to friendliness. Any questions so far? Yes?
Why did we only do 2 for function 1 and 1 for function 2?
Oh, thank you. We could do 2 for function 2 as well. So you pick the next second largest number, maybe job test result, but 0.859 is far away from 0.105. So we pick the biggest one for function 2. For function 1, we pick 2 because those 2 are pretty close, 0.9, 0.4. It is not like far away from 0.859 compared to 0.105. Okay.
0.428 really close to 4.67. So wouldn't you also pick that one?
You could, yes, you could also pick that one. Yeah. But usually we just pick one most important. So for function 1, you pick 0.953. For function 2, you'll pick 0.859. So during the final exam, it will not have ambiguous. I will just maybe ask you, what is the biggest contributor for function 1? Which one contributes the most for function 1? The answer only has one, job test result, because it has biggest number, 0.953. Okay. Thank you for your question. Any other questions? All right, so this is a structure matrix table. Okay, we turn back to our output here. Last table I need to explain is the classification table. Classification function. So I will copy classify function. Oh, not this one. We already did that. Classification function here. I should have a classification function. I don't have that result. Maybe I missed some selections. I need the classification function result. So So I will maybe just copy from the textbook result. So what I need. So we explained all those tables. The last one I need to explain is this table here, classification result. Yes?
It's at the very bottom of the output. If you go to your output and scroll all the way down past the chart.
Oh, I do have that one. Oh, thank you so much. Yes, it is the last one. Good job. Thank you. Remind me your name.
Jacqueline?
Oh, yeah, Jacqueline. Thank you so much. So I'll just right click my mouse. I have this result here, copy. Yeah. Paste. Remember at the beginning of our data analysis, if we check our original data, we are saying the first person would belong to group 1, the second person belong to group 3, the next person group 3, the fifth person group 2, the sixth person group 1, etc. Okay, those are our prediction. And remember, we also have data here, see? Originally, the first person is group 1, and we predict group 1. We did great job, right? The second person is a group 3. We predict group 3, but this person here, the sixth person, originally this person is group 3, but we predict this person is group 1. We made mistake. Did you see? That means our prediction is not 100% correct. We did put person in the wrong group. When we predict. Okay. So how accuracy is our model? You go to this table here. Go to the bottom, the last one here. You see, 62% is the accuracy. Out of 100 cases, we can successfully predict 62 cases. Is that clear? That is pretty high percentage. In most researchers, even they can predict maybe 48%, they're very happy. Okay, we got 62%. Okay, so that is the number you need to know. That's it from the classification results. Okay. All right. And also this, the chart output here. We have the chart output. And this chart, you can only available from analysis process. Remember, we selected combined group under the plot selection combined group. How do you interpret this one? It has the I'll copy this. Maybe just use this one. So for this function, we have 3 groups. Remember, we have 3 groups. This part is a poor performer. Here, look at my mouse. And this is individual achiever. And this is, what is this? Team player. So team player is in this color, pink. Okay. If our model is 100% perfect, if our model is perfect, perfect means we can make 100% prediction. If that is the case, this diagram, when you see the purple, then the purple all with purples. But here, under the purple cluster, we also see this blue here. That is the misclassification we put because we cannot 100% predict. We did only 62% correct. Is that clear? Okay, so this is the interpretation of this graph. All right. So in summary, what we did today, we did discriminant analysis. Discriminant analysis allow us to make prediction about group membership. And in discriminant analysis, variable y must be categorical variable. You cannot use continuous variable as y. Okay, it's only categorical variables. And then we have assumptions for conducting discriminant analysis, 3 assumptions. And we also introduce some terminology like determinant function, effect size, weakest lambda, okay? Centroid, function and centroid, very important table. Structure mix, very important table. Those are the 2 most important tables in the discriminant analysis. Okay. So that is for the lecture part. Any questions? And remember, each lecture we have exercise. Those exercises are part of your assignment, 10%. So because we have some time, I would suggest you do the exercise from lesson 35 in class. If you have questions, you can ask. But the due date is March 17th, the assignment. And also remember, we have 1% in class exercise. I believe the link is available. So go to the test link on Sakai and click week 7. The due date is by 4 o'clock. Just 2 questions, okay? 2 questions. All right, so I'm going to check the online students' message. Any questions, people on the online? Where is the textbook? We can find exercise. Okay, James, textbook. You have to buy textbook from the campus bookstore. This is how the textbook looks like. This one here, SPSS for Windows and Macintosh. The specific information about the textbook, you go to Sakai, resources, course outline. This is textbook information. This is our textbook. Okay. Thank you for your question. Another question is, at the end of each chapter, there will be a lesson tell you which SPSS file to use to answer them. Thank you, Eric. Yeah, that's correct. At the end of each lesson. Okay, thank you, Jacqueline, for your contribution. Okay, so for example, at the end of lesson 35, where is my, at the end of lesson 35, accept. Go to next page. See, this is your part of your assignment, exercise, lesson 35. Okay, 1, 2, 3, 4, 5. Maybe I will help you to do 1, 2, 3, 4, 5. Do you want me to do it? Lesson exercise, that is your assignment, or you are okay to do it by yourself?
Can you help us?
Oh, okay, yeah. So I'm going to give you a demonstration. How do you do the assignment? Okay? Okay, great. So it is, why does okay. So I'm going to do 1, 2, 3, 5, those 5 questions. Maybe not the last one, you do the last one, okay? Write a report. Create, I will do question 1, 2, 3, 4 on page 224. Okay, as a demonstration, how do you carry out your assignment? Okay, I'm going to copy. Okay, I will try to stop recording, then I will start recording again because this is a separate exercise. Just drink some water.